Right now, in the palm of your hand, sits the single most complicated object the human species has ever built, and you carry it around like it's nothing. If you're being honest with yourself, you have almost no idea how it was actually made. Not the apps, the physical thing itself, the glass, the polished metal shell, the battery, and the impossibly tiny brain buried somewhere deep inside it. You paid for it, you own it, you call it yours. But here is something strange that almost nobody ever stops to consider. You couldn't build even one single piece of it yourself. Not the screen, not the battery, not even one of the screws. And that isn't an insult aimed at you. It is equally true for every single person alive on this planet today. So let's actually prove it. Let's try, step by step, to build a working phone completely from scratch, from absolute zero. No factories, no online orders, no stores, just you, the raw planet under your feet, and a plain gray rock off the ground. It sounds almost simple, but by the end, this rock is going to teach you something genuinely unsettling about your whole life. Let's start with the screen, because that part looks like the easy one. The screen is glass, and glass is really just melted sand. So you walk to a beach, scoop up a handful of sand, build a fire, and melt it. Done, right? No, not even close. Ordinary beach sand is filthy, full of salt, crushed shells, and iron. Melt it, and you get a cloudy green lump you can't see through. A phone screen needs quartz that is almost perfectly pure, and even then, ordinary glass would shatter the first time you dropped it. So your screen isn't ordinary glass at all. It's a special toughened glass, like the Gorilla Glass made by a company called Corning. They bathe the finished glass in a tank of molten potassium salt around 400 degrees for hours. Down at the atomic level, small atoms are swapped for bigger ones that jam into the surface and hold any cracks shut. That one trick took Corning decades to perfect. You are not doing that with a campfire, a bucket, and good intentions. Fine. Forget the screen for now. Let's make the metal frame instead. That frame is almost always aluminum. Aluminum is the most common metal in the Earth's crust. It's literally all around you. So surely, this one will finally be free. Here's the secret almost nobody ever learns. For most of human history, pure aluminum simply did not exist. In the 1800s, it was rarer and more precious than gold. The Emperor of France served his guests on aluminum plates. Everyone else at the table got mere solid gold. So why was such a common metal so rare? Because aluminum hides. It never shows up as a shiny nugget you can dig out. It stays chemically locked inside a dull, reddish rock called bauxite. And to tear it out of that rock, a hammer is useless. You need lightning. You have to drown the rock in electricity. Pure aluminum only became possible once humans could generate enormous amounts of power. One soda can holds as much energy as a stick of dynamite. So before you can even shape your frame, you first have to go and invent the entire electrical power grid, dams, turbines, copper wires for hundreds of miles, all just to make one slim piece of metal you'd toss in a drawer. And believe me, we still haven't reached the hard part. The hard part is the chip. The brain of the whole phone. It's a sliver of silicon smaller than your fingernail, and packed onto it are billions of microscopic switches called transistors. A modern phone chip holds around 15 to 20 billion of them. Each switch is far smaller than a single virus. Silicon also starts as sand, but not just any sand. The purest quartz on the entire planet comes from one tiny town, Spruce Pine, North Carolina. A few thousand people. Almost every advanced microchip on Earth traces back to that one quarry. If that single quiet town stopped shipping its sand, the entire digital world would slowly grind to a halt. And even that ultra-pure sand isn't clean enough. You must refine the silicon to 99.9999999%. That's one stray atom allowed per billion. One. Then you grow it into a single flawless crystal the size of a log. You pull it slowly out of the molten silicon, turning it over many hours. Now you have a perfect but completely blank crystal. You still have to carve an unimaginably complex circuit into it, and you carve it not with a blade, but with light. The patterns are so small that normal light is too clumsy. Its waves are simply too fat to fit between the lines. So you need extreme ultraviolet light, and to make it, you fire a laser at a tiny droplet of molten tin, 50,000 times a second, blasting each droplet into glowing plasma. That light bounces off the smoothest mirrors ever made. Mirrors so perfect that, Blown up to the size of a country, their largest bumps would be only a few atoms tall. The single machine that does all this is, without exaggeration, the most complex tool our species has ever built. Exactly one company on Earth can make it, a Dutch firm called ASML, and even they can't build it alone. The mirrors come from a German company, Zeiss. The other parts pour in from thousands of suppliers across dozens of countries. Each machine costs more than a passenger jet, and it's so huge it ships in pieces aboard several cargo planes. So to make your one chip, you first need that machine. And to make that machine, you need 100,000 other parts. And almost all of the world's most advanced chips are printed on one single island, Taiwan. Are you seeing the pattern yet? Let's pretend you somehow now have a chip. Good, because now you need a battery. And a battery needs lithium and cobalt. Most of the world's cobalt comes out of a single country, the Democratic Republic of the Congo, deep in Central Africa. A lot of it is dug by hand, sometimes by children, scratched out of the red earth for almost nothing at all. Your sleek, beautiful glass rectangle has a quiet, uncomfortable, often ugly human story buried inside its battery. The lithium, meanwhile, is boiled out of gigantic salt lakes high up in the dry mountains of South America. They flood the desert and wait for the sun to evaporate it. For months. It can take years and millions of gallons of water for one batch, and the battery is only the start. Your phone contains around 60 different elements, more than half the periodic table. Tantalum for the capacitors, again from the Congo. Tin to solder the joints, much of it from Southeast Asia. Copper to carry the current. Rare earth metals to make it vibrate in your hand and to paint color across the screen. And a tiny bit of real gold in the connectors, simply because gold is the one metal that never rusts. To gather every one of these materials yourself, by hand, you'd be mining on 3 different continents before lunch. So, realistically, how long would it take one person to build a single phone, completely alone, starting from a bare rock? We actually have a clue because a man once genuinely tried something far simpler and wrote down everything that happened. A British artist named Thomas Thwaites set out to build one basic electric toaster entirely from scratch, all by himself. Not a phone, a cheap toaster. Just 5 main materials. It took him over 9 months and trips to old abandoned mines. He even tried to smelt his own metal in a microwave oven, leaning on crude techniques from centuries-old textbooks. And his hand-built toaster melted itself into a sad lump the instant he plugged it in. And that was just a toaster. Your phone is thousands of times more complex. Decades earlier, a writer made the same point about a single wooden pencil. He argued that not one person on the entire earth actually knows how to make even a simple pencil, completely alone, from scratch. The wood, the graphite, the metal ring, the paint, the rubber tip, each is its own deep world. And if that's true for a pencil, then here is the part that should genuinely stop you cold. No single human being on this planet knows how to make a smartphone. Not one brilliant engineer, not one factory boss, not the richest, most powerful CEO in the entire world. Nobody. The miner who digs the cobalt can't design the chip, and the genius who designs the chip can't refine the metal or grow the crystal. The knowledge to build a phone isn't missing. It's something stranger. It's shattered, scattered across millions of separate strangers, people who will never once meet, who speak different languages in countries that very often don't even trust each other. And yet, somehow, every single day, that vast invisible web quietly places a finished phone right into your waiting hand. You didn't earn it with your own skill. You inherited it, freely, from the entire human race. Thousands of years of cooperation resting in your palm. So the next time you hold your phone and casually call it yours, just stop for a second and remember what it really is. You're holding a small, glowing piece of the entire human species, gathered together from every far corner of the world. You, completely alone, could never build it. But all of us, scattered and separate as we are, somehow, together, can. And maybe that is the most human thing about it.